Roman candles. 27. Fireworks of this species are exceedingly beautiful and effective, especially when made with colored stars and fired in numbers. Their manufacture is somewhat difficult, but the difficulty is one well worth overcoming. I made a considerable series of experiments before I produced a Roman candle that answered my expectations. At last, however, I hit upon a plan which has never since failed in my hands, and I think that, if I can succeed in making my meaning understood, and you will undertake to follow my directions closely, you will find my plan a good one. There are several conditions upon which success depends, and which it will be as well to enumerate. A poor Roman candle is not worth making. If you wish to produce one that will satisfy you, remember, first, that you must have a composition to burn in the intervals between the stars, which will produce as good an effect when the Roman candle is almost spent as when first lighted. In fact, which will throw a jet of fire uniformly good throughout. Second, that your stars must be hard enough to resist the pressure of the drift with which you consolidate the composition. Third, that the stars must be of tolerably rapid combustion, otherwise they will not be ignited before they are blown into the air. Fourth, that the charges of powder for blowing the stars must be regulated to a great nicety. If too small, they will not throw them high enough. If too large, they may burst the case, or spoil the intended effect of the stars, or so disturb the composition below them that 3 or 4 of the stars will be fired in rapid succession, or almost instantaneously. Now, the first thing to be considered is the size of which Roman candles are to be made. I make them of one size only, for I have found that it is much more convenient to have but one size of stars to prepare, and one size of cases to roll, and one scale of powder charge to remember, than to run the risk of confusion by having to think of various sizes. Besides, all the effect that these pieces are capable of can be produced by my one size. This size is that called the 2-ounce Roman candle. The former for the cases must be 5/8 of an inch in diameter, and should be 18 inches long. These fireworks require rather a large amount of paper and imperial board for the manufacture of their cases. A good stout case may be made as follows. Cut your sheets of 70-pound brown paper into halves, and your sheets of imperial board into 6 equal pieces. One of these pieces, with 1/2 sheet of 70-pound paper, will make 1 case. Paste your pieces of imperial board all over, as well as the sheets of paper. Rub some paste on your former, and proceed to roll a piece of the pasted board tightly and smoothly round the former, till all but about 2 inches of it is rolled. Then take the pasted half-sheet of brown paper, and roll this upon the imperial board in the manner described for making golden rain cases. The method there given is of especial value when the cases that you are making are of considerable length, because it enables you to roll the paper and board very straightly, which cannot be done so easily by any other means that I know of. The cases thus made will be pasted throughout, and can be easily removed from off the former. They will be about 14 inches long, which is a very good size. You can, of course, make them shorter for experiments, but you will find the above size not too large for exhibition purposes. I do not think it will do to make the cases very much thinner than I have directed, but a few experiments will decide what length or thickness of case succeeds best in your hands. I have given you my size, which I have no wish to alter. White Roman candle stars. 28. The brilliant stars may be made of the same composition as that given you for rocket stars of that kind. If, however, you require a more white star, use the following. White Roman candle stars, composition number 1, niter, 48 parts, sulfur, 10 parts, regulus of antimony, 8 parts, realgar, 6 parts, red lead, 4 parts, shellac, 1 part. This formula gives a much purer white than the formula for ordinary brilliant stars, which are always bluish in tint. Composition number 1 must be moistened with the solution of shellac recommended for rocket stars. Yellow Roman candle stars. 29. Yellow Roman candle stars may be made from the same formula as that given for yellow rocket stars. Green Roman candle stars. 30. Green Roman candle stars may be made from the formulas given for rocket stars. But there is also another formula, which produces a rather deeper tint, but is hardly rapid enough in combustion for rocket stars. It is the following. Green Roman candle stars. Composition number 2. Nitrate of baryta, 40 parts. Chlorate of potash, 20 parts. Calomel, 12 parts. Sulfur, 12 parts. Shellac, fine, 4 parts. Charcoal, fine, 1 part. This composition must be moistened with the solution of shellac. It will produce a most lovely color, if the baryta be pure. Crimson, rose, blue, and purple Roman candle stars. The formulas for crimson, rose, blue, and purple Roman candle stars are the same as given for rocket stars, and must be moistened with the liquid directed in my last paper as proper for each one. You have now formulas for making brilliant, white, golden, green, crimson, rose, blue, and purple stars. Roman candle stars. To make. 32. In order to make the stars, moisten the compositions very slightly. The mold in which these stars are shaped is a brass tube of a size proportioned to the size of the Roman candle case, and is generally about 1/16 of an inch smaller in its inner diameter than the case. The drift with which the composition is pressed into the tube is made of boxwood or metal, and fits easily into the tubular mold. At one of its ends there is a wire point. Place the end having the point in the mold as far as it will go. You will find a space left at the end of the mold unoccupied by the drift. Press this empty end of the tube into the slightly moistened composition until it is filled by it, so that the drift, being driven down upon the composition, will compress it into a firm cylindrical mass, into the center of which the wire point projects. Figures 35, 37, and 39 represent the mold, drift, and finished star. When the star is thus formed in the mold, the drift must be reversed, and its long plain end inserted, and the star pushed out. The object of making the star hollow is that it may dry and harden perfectly in its center. If heat is employed to dry the stars, they have a tendency to harden outside rapidly, and thereby an impervious coating is formed, through which the inner moisture cannot evaporate. This difficulty is obviated by leaving a hole in the center of the star, and this hole is made of use for another important purpose, namely the priming of the star. My plan for ensuring the ignition of the stars is, as far as I know, peculiar to myself, and I have the satisfaction of knowing that it has never failed me. Some pyrotechnists recommend the smearing of the star with a very combustible paste. This plan, however, must to some extent injure the color of the star. I simply place a little piece of quick match into the hole in the star and allow it to project about 1/4 of an inch above. By this means even slowly combustible stars are ignited, and almost every chance of failure is avoided. This priming, however, should not be done until the stars are to be put into the cases, at all events till they are perfectly dry. Their drying may be effected naturally out of doors in the summer, when a very few hours' exposure in the sun will render them thoroughly hard and fit for use. In the winter time, however, artificial heat should be used. I always find that the more rapidly, up to a certain point, these stars are hardened, the better they keep. Nothing, however, will be gained by hurrying them through this process, except a danger of their exploding. Place them carefully, and not touching one another, in a tin box having a lid, and let this box remain at such a distance before a fire that it can become thoroughly warm, not hot, till the stars are thought hard enough to be put away. They should be kept, when dry, in closely stoppered bottles in a dry place. Each star will weigh at least 30 grains. Composition for Roman candles. 33. I must now suppose your stars and cases to be ready for use, and therefore the next thing to be considered will be the composition which is to form the intervals between the stars in the cases. For this purpose I give you 3 formulas. Composition for Roman candles. Number 1. Niter, 18 parts. Sulfur, 6 parts. Charcoal, fine, 7 parts. Meal powder, 4 parts. This composition is one which answers very well. I think, however, that the following is better, being rather more rapid in its combustion, and thus capable of producing a more decided effect when burning at the lower end of the case. Number 2. Niter, 16 parts. Meal powder, 8 parts. Charcoal, fine, 6 parts. Sulfur, 6 parts. This is the composition which I generally employ. Both of these formulas give rather a dusty mixture, and can be used with much greater cleanliness and comfort, if slightly moistened. Only so much spirits of wine or gin must be used as will render them less dusty, and not wet. The following composition is very useful, but produces rather a jet of flame with sparks than a rich, sparkling fountain. Number 3. Niter, 16 parts. Meal powder, 11 parts. Sulfur, 6 parts. Antimony, 4 parts. This composition is of a more heavy and less dusty nature, but can also be slightly moistened if you find it more convenient to use it when thus treated. Take care that in each case the ingredients are well mixed. Roman candle cases to fill. 34. Having selected one of the above compositions, you will now be ready to fill your cases. For this part of your work, you will require a small turned block of wood, like that drawn in the page of illustrations, figure 40. This block with its projecting piece is called a settle. One end of your Roman candle case is pressed over the upper part of this settle, which is made of a size to fit into it tightly. By this means the case will be supported while it is being filled. The first thing to be done is to close up one end of the case. This is done by ramming in a small quantity of dry potter's clay, such as you used for rockets. This being driven down over the top of the settle will form a very hard, firm end. Charges for Roman candles. 35. We now have to enter upon the most difficult part of the manufacture of Roman candles. This is the regulation of the charges of powder, which are to blow the stars into the air. These are so small, and necessarily so, that unless their quantity be very accurately measured, you are very likely to spoil the performance of the whole. The following table will give you an approximate idea of the quantity that each charge should contain, but so much depends upon the quality of the gunpowder which you employ, that it is impossible to give you anything more than an approximation. For the first star, 3 grains. For the second star, 4 grains. For the third star, 4 grains. For the fourth star, 5 grains. For the fifth star, 5 grains. For the sixth star, 6 grains. For the seventh star, 6 grains. For the eighth star, 7 grains. For the ninth star, 8 grains. For the 10th star, For the 10th star, 30 grains. Gunpowder exerts more or less force in its combustion in proportion as it meets with more or less resistance. It is in accordance with this principle that those charges of gunpowder which are at or near the lower end of the Roman candle case are obliged to be much smaller than those placed nearer its mouth. If it were not so, and all the charges were alike, when the combustion reached a certain point, the case would be burst. You must modify the quantities given in the above table until you produce the greatest and best effect with the greatest economy of power. I think that the 5 first charges will not require to be altered much. I have given charges for 10 stars. You need not, of course, put so many into the case, but you should not put in less than 8. All must depend in this matter upon the quantity of composition which you like to use in the intervals between the stars. Only be sure to keep the last 2 charges of gunpowder always the same, and do not place the 2 last stars too near the mouth of the case. The reason why these rules must be observed is that the force of the charges of gunpowder which lie near the mouth of the case is so soon spent that if the stars are too near the mouth of the Roman candle, they will do little more than fall out of the case, instead of being blown to their proper height. The first star means not that one which is fired first from the Roman candle, but that which is first put into it. Your best plan for measuring the charges of powder is to have some small scoops or ladles made of very thin sheet brass, of the same shape as that used in filling rockets, and capable of holding exactly the right charge of powder for each star. This is the only plan that I am aware of for ensuring with any accuracy the various quantities. Now, having your stars primed, as directed above, with quick match, your clay rammed firmly into the lower end of the case, and your composition ready moistened for use, you must cut some thin touch paper into squares of 1 inch in size. Next you must be provided with a round stick with a flat end, which will pass easily into the case from one end to the other, not shorter than 18 inches. Your materials and apparatus are now complete. First put into the case the first charge of gunpowder, and take care that this finds its way to the bottom of the case. Drop in next the first star, with its priming upwards. Take care also that the star lies directly upon the charge of powder. Now, by means of another brass scoop made to hold the proper quantity of composition, put into the case half the quantity that is to be rammed between the first and second stars. You must then press this into its place by means of your ramming stick. This can be done with the hand, without any mallet. The weight of a mallet would break the star beneath. Remember always to ram in the composition which is to form the interval between the stars in 2 quantities. If you attempt to ram it all in at once, it will not be sufficiently consolidated, and its combustion will be too rapid. The quantity of composition must depend entirely upon your own taste. I generally put in as much in 2 quantities as will rise about an inch in height in the case. It will not do to put in less. Then, upon the top of this composition, put one of the square pieces of thin touch paper. This may be rammed down in the same manner in which a gun wadding is driven upon the top of the charge. The object of this little piece of touch paper is to prevent the charge of powder which is above it from disturbing in its explosion the composition which is below it. This I have always found it most effectually does, and allows, moreover, of the use of a rather stronger charge of powder than could be employed without it. Having put this in flatly, measure out your second charge of powder, and put upon the top of it your second star, then another half charge of composition, then the remaining half charge, then another piece of thin touch paper, and so on, till the case is filled. The last charge of powder should not be less than 2 inches below the mouth of the case. The Roman candles should always begin with composition in their burning. Arrangement of stars. 36. With regard to the arrangement of the stars, I generally vary the colors as much as possible in each Roman candle. If these pieces are to be fired singly, it matters little what the order of the colors is. But if they are to be fired in numbers, it will be necessary to arrange them so that they do not throw up the same colors at the same time. The plan that I adopt to prevent this is the following. I make out a list of the colored stars that I have ready to use, arranging them, for instance, in the following order: brilliant, green, yellow, blue, red, white, purple, rose. The first Roman candle may be filled with its stars in this order. In the second I should begin with the green, in the third with the yellow, and so on, till all that are to be fired at once are completed. Preparation of touch paper. 37. I have spoken about touch paper, but I do not think that I have yet described its preparation. This is very simple. Obtain some thin blue paper, not so thin as tissue paper, but thinner than the ordinary blue paper used by shopkeepers. Brush or sponge this over with a weak solution of niter. If this solution is made too strong, the niter will recrystallize as the water evaporates in drying, and this should not be the case. Quick match. 38. Quick match, of a quality good enough to answer for priming to the Roman candle stars, may be made simply as follows. Make a thick paste of gunpowder and hot water, with a small quantity of gum in it. Take about 4 strands of cotton, such as is sold in balls and used for making the wicks of lamps. Steep this in the solution of niter used above for making touch paper, and then wring it as dry as possible. Then rub it well in the gunpowder paste till it is thoroughly covered with it. One end of the cotton may then be passed through a small funnel, whose mouth is not more than 1/8 of an inch in width. By this means, if the whole length of the cotton is drawn through it, the superfluous paste will be removed, and the match will be of a nice round form. Hang it out of doors on a dry day, and when it is nearly dry, coil it upon a tray or paper, and dust it over with meal powder. In winter it will not be sufficiently dry for use under a week. When thoroughly dry, it should be stiff and hard, and the less it is bent or doubled, the better. If you wish to use this match for connecting the mouths of different fireworks, or clothing them, as it is termed, you must make some long paper tubes round a wire former, which has a diameter of not less than 3/16 of an inch. These pipes are threaded on the match, and have a piece cut away at their side, wherever they are inserted into the mouth of a case, in order that the match may be laid bare and convey its fire to the priming of the cases. I have given you these short hints for the preparation of a quick match. I cannot, however, recommend your acting upon them, as the manufacture of this useful article involves a great deal of very dirty work. Unfortunately, quick match is rather expensive to buy, while it may be made at a very trifling cost. It is a most indispensable accessory, and if you dare face the dirty work, you will find your courage will well repay you. You may prepare it any way that you please, remembering that all that is necessary is to coat the cotton well with a highly combustible compound, and one which will dry thoroughly. Your Roman candles, when charged, should be finished with touch paper, or with ordinary paper, to receive the quick match, if they are intended to be fired simultaneously in numbers. I trust that the above directions will enable you to succeed in the manufacture of a species of firework without which no exhibition can be complete, and with which so many and beautiful effects may be produced. In case you should prefer to buy your chemicals and various ingredients of an operative chemist, I beg to refer you to Messrs. Bolton and Company, 146 Holborn Bars, London, in whose preparations I have great confidence, and who will undertake to supply you with all the articles required in pyrotechny at the prices in the subjoined list. You will perceive that it is much more economical to purchase them by the pound whenever they are required in such quantities. Many of the things, however, you will need to use only sparingly, and these, therefore, may be bought by the ounce. I think the following list will be found to contain nearly all the preparations that you will require. There may be a few things omitted, such, for instance, as red lead, used in the composition for white Roman candle stars, but this can be procured of any country chemist or painter. Nitre in powder, 8d per pound. Meal powder, 1 shilling per pound. Sulphur, 4d per pound. Charcoal, 4d to 8d per pound. Calomel, 5 shillings per pound, 4d per ounce. Nitrate of strontia, 1 shilling per pound, 1d per ounce. Nitrate of strontia anhydrous, 2 shillings per pound, 2d per ounce. Nitrate of baryta, 1 shilling per pound, 1d per ounce. Nitrate of baryta anhydrous, 2 shillings per pound, 2d per ounce. Chertsier's copper, 4 shillings 6d per pound, 4d per ounce. Oxalate of soda, 3 shillings per pound, 3d per ounce. Shellac in powder, 3 shillings per pound, 3d per ounce. Sulphide of copper fused, 2 shillings 6d per pound, 2d per ounce. Realgar, 2 shillings per pound, 2d per ounce. Carbonate of strontia, 2 shillings per pound, 2d per ounce. Stearine, 2 shillings per pound, 2d per ounce. Regulus of antimony, 1 shilling 9d per pound, 2d per ounce. Bright steel filings, 1 shilling per pound, 1 pence per ounce. Cast iron borings, 6 pence per pound. Powdered glass, 1 shilling per pound, 1 pence per ounce. I have now only to give you a brief description of the woodcuts. Figure 34 represents the funnel into which golden rain composition is placed. Figure 35, the drift with which it is rammed. Figure 36, the case which is to contain it. Figure 37 represents the tubular Roman candle star mold. Figure 38, the drift with which the stars are rammed. Figure 39, the finished star with its quick match priming. Figure 40 represents the settle with its upper part on which the Roman candle case is to be supported. The next portion of our subject with which we have to deal is that which comes under the head of gerbes and jets of brilliant Chinese and common fire.